In this video, we'll discuss how to form the equation in a 3D space. For this one, first of all, we'll discuss the concept of the parallel lines and the parametric form T. Consider any vector which represents a vector in a magnitude and in direction. Let's say this vector is A. Now consider that if we shorten this length, the direction will remain same, but the magnitude will go on decreasing. So this we can represent by a small vector. This vector is the same direction as A, but is shorter than the vector A. So we can write this in the form of T into A bar, where T is any parameter which can accept any value, maybe 0.1, 0.2, 0.3. Suppose we show the vector like this. So this vector is also parallel to A. So we can write as T times A bar. This time value of T will be greater than A. And suppose we show the vector in opposite sense. So this one is T into A. This time the value of T will be negative value. So what in general is that on this any vector, if we generate a vectors like this one, the starting point here, that is T is equal to 0. And if we are at the end points of this one, T is equal to 1, using the previous concept. And if you go on increasing the value of T, you will get the same points on the same vector for T greater than 1. And if we extend on this side, it means that the value of T is less than 0, that is negative value. So this is the idea used basically to form the equation of a line in a space using a parametric equation of T. So this concept we are going to use in this video. Let's consider this was any vector, and if we draw the same vector, but this time I am drawing just offset, but it is the same parallel vector. Just by increasing the value of T from 0 to 1, we can go to the other side, and for T less than 1 we go to the negative side. So using the parametric form T from all values, we can generate the equation of straight line. So to generalize this, let's consider here a three-dimensional sketch XYZ axis system. X-axis, Y-axis and positive of Z-axis. And let's consider here 2 points that is normally provided to you. One point is A, other point is B. And let's join these two vectors. And we want to form a equation of line passing through AB. Let the coordinate of point A is x1, y1, z1. And the coordinate of point B is x2, y2, z2. And let's consider the P is the current point on the line having coordinate x, y, z. Now in this case the AP vector and AB vector, they are parallel vector. So we can use the same concept that we have just developed, that is AP vector is T times the AB bar vector. So this one is AB vector and this vector is parallel to AP bar vector. So we have AP bar is equal to T times AB bar, where T is any parameter. T is not time. Now we can write AP bar as x minus x1 times I plus y minus y1 j plus z minus z1 k equal to AB bar we can write as x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. And now this time we can equate the quotient of I. So if we equate the quotient of I, we get x minus x1 is equal to t minus x2 minus x1. So we can solve for x. We get x is equals to x1 plus t times x2 minus x1. Similarly, we can generalize this equation as y is equal to y1 plus t times y2 minus y1. Similarly, z equal to z1 plus t times z2 minus z1. So it's a very simple procedure to find out equation of a line. Now if we put t is equal to 0, we will get x is equals to x1, y is equal to y1, z is equal to z1. That is p is same as a. And if t is equal to 1, we will get x to x2, y is equal to y2 and z is equal to z2. That is p is equal to b. So these values are always fixed. At t is equal to 0, we have start point, and at t equal to 1, we have end point. So this is one sort of question they can ask you to find out the equation of a line when they will provide 2 points. And you can cross check your answer by putting t equal to 0 and t equal to 1 and obtain the start point and end point. So if you solve this equation for t, you will get x minus x1 upon x2 minus x1. This is called as parametric form. Y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1, So you just remember one term of x and you can repeat this for y and repeat for z also. Suppose you are given one point in the space as x1, y1, z1, and we are given one vector somewhere in a space v bar vector, and we want a line which is parallel to v bar and passing through A. Let the v bar vector is ai plus bj plus ck. Now since we want a line passing through A and parallel to v bar, so what we do is that we'll just copy down this line and we'll pass this line through point A. So we'll get all the points on this line. And remember, this equation is t times v bar because it is parallel. So any vector you take of v bar, then that vector will be equals to t times v. So we'll cut that part and we'll paste on the same line. So this part will be t times v bar. And just by changing the value of t, we can obtain a different successive position of current point P on the line that we are interested. So we can write this time the AP bar is t times v bar, and then we can vary the value of t from all values. Then we can generate all points on the line, including the negative value as well as positive value. So what we conclude is that AP bar must equal to t times v bar. So we have AP bar is equals to coordinate of P minus coordinate of A, that is x minus x1 times I, plus y minus y1 times j, z minus z1 times k is equal to t times v bar. V bar is ai plus bj plus ck. Now just again compare the coefficient of I, j and k. We'll get x minus x1 is equal to t times a. So we have x is equal to x1 plus t times a. So we can generalize this now. We have y is equal to y1 plus t times b, z is equal to z1. So take one example based on this one. Find parametric equation of a line that passes through the point minus 2, 0, 4 and 0, 4, 2. So let's consider point A here, minus 2, 0, 4 and point B here, 0, 4, 2. And let's consider any point in between A and B, the current point on the line. P is equal to x, y, z. So first of all, we'll form the vector AB bar. So AP bar will be equal to t times AB bar. So AP bar will be equals to coordinate of P minus coordinate of A, x plus 2I plus y minus 0, that is yj, plus z minus 4 times k. Now we have t times AB bar is coordinate of B minus coordinate of A is 0 minus 2 is 2I plus 4j minus 2k is multiplied by t. So t I have forget to write here. So this is multiplied by t. So we have x plus 2 equal to 2t. That is, we have compared here the coefficient of I. From this we can get x equal to 2t minus 2. Now we will compare the coefficient of j, which is y is equals to 4 times t. And lastly we compare the coefficient of k, which is z minus 4 is equal to minus 2t. So we have z equals to minus 2t plus 4. So at any time t equal to 5, you can find out the coordinate of x. Just substitute here, we will get x equal to 8, y is equal to 20 and z equals to minus 6. Put t is equal to 5. In this problem, you have to find out the parametric equation. You are given one point and you are given one velocity vector v equal to 2i plus 4j minus 2k. So this vector represents v bar is equal to 2i plus 4j minus 2k. And let's say in a space we have one point minus 2, 0, 4. Let's label this point as a point minus 2, 0, 4. And now we'll draw one line which is parallel to this line. So we are interested in this line, and now this line we are passing through point A. Now here let's consider any point on this line is the current position of the point x, y, z. This vector is AP bar and this vector is parallel to V bar. So we can write AP bar is equal to t times V bar. So using this we can form the equation of line. So we have AP bar equal to t times V bar. AP bar we can write as coordinate of P minus coordinate of A. X minus minus 2 is x plus 2I plus y minus 0 is yj plus z minus 4 is equal to t times, and v bar is 2i plus 4j minus 2k. Now this time, to solve it further, we'll compare the coefficients of I, j, k. So if we compare the coefficient of I, we'll get x plus 2 is equal to 2t, which can be solved for x as 2t minus 2. Similarly, we can compare the coefficient of j. So we have y is equal to 4 times of t. And now we'll compare the coefficient of k. So we get z minus 4 equal to minus of 2t. So we can write z equal to 4 minus 2t. And we can cross check our equation is correct or wrong. Since we know only one point, so it is better to put t is equal to 0. So at t is equal to 0, then p will move to point A. So we have t equal to 0. We'll get x is equals to minus 2, y is equals to y equal to 0, and z equals to 4. So this is same as the coordinate of point A. So the solution is correct. Maybe ask that they have given one line and they ask you to find out the shortest distance. So we have given here one equation line, x equal to 1 plus t, y is equal to 3 minus t, z equal to 2t. And you want to find out the shortest distance between 5 and 5. So we will consider here one point A at t is equal to 0. T equal to 0 I have selected because it is very quick to calculate. So we will get x equal to 1, y is equal to 3, z equal to 0. Similarly, we can find out t is equal to 1 very quickly. So we get the coordinate of point B is equal to 2, 2 and 2. Now we will show here one point somewhere in the space. Let's say this is any point here which we are interested to find out the shortest distance between the given point and the line AB. So this point is coordinate 5, 1, 5. Now we are interested in the shortest distance, means perpendicular distance. So we want to know this distance, exactly perpendicular distance in a space. Let's say this distance is equals to D. And for finding this one, we'll use the right angle triangle rule. Let's say this point is C point, and let's say this angle equal to theta. So distance D we can calculate as AC multiplied by sine theta. So distance D will be equal to mod of AC, that is the length of AC vector, into sine theta. Now where your sine theta will come, you can always think of cross product. And if the cos theta will come, you can think of dot product. So what we'll do, we'll first take cross product of AC bar and AB bar. And then we'll take the mod. Then automatically we'll get this answer. So first of all, to find out the cross product AB bar and AC bar, we'll first find out the vector AB bar. Vector AB bar means coordinate of B minus coordinate of A. 2 minus 1 is I. 2 minus 3 is minus J. 2 minus 0 is plus 2K. And we can also find out modulus of AB. Modulus of AB is under root of 1 square plus 1 square plus 2 square. That is equal to root 6. Similarly, we can find out AC vector also. The coordinate of C minus coordinate of A. 5 minus 1 is 4i. 1 minus 3 is minus 2j. 5 minus 0 is plus 5k. And we can find out modulus of AC bar also. Under root of 4 square plus 2 square plus 5 square. 16 plus 4, 20 plus 25, 45. Root 45. Now we'll take the cross product of AB bar cross AC bar is given by mod of AB bar into mod of AC bar into sine theta. If I take the modulus of this vector, because the last term is unit vector and the magnitude of unit vector is 1. What we are interested in the distance D, and this distance D is mod of AC into sine theta. So we want to just find out the cross product and divide by AB bar. To find out this distance D, we have to find out the AB bar already known. We have to just find out the cross product. So we can find out cross product using determinant. First row will be ijk. Then you have to write down coefficient of AB, that equal to 1 minus 1 plus 2. Then you have to write down coefficient of AC, 4 minus 2, 5. And you can solve this. To solve for I, minus 5 plus 4 is minus I. Second term is negative, plus 5 minus 8. Since the second term is negative, it becomes plus 3j. Third term is for k. 1 into 2 minus 2 plus 4 plus 4, that equal to plus 2k. And now we want a modulus of this. So modulus of this one will be under root of 1 square plus 3 square plus 2 square. 1 plus 3, 9. 9 plus 4 is 14, root 14. And AB bar is already known to us, root 6. So in this fashion, we can find out the shortest distance. So shortest distance will be under root of 14 by 6. That can be solved.